You know that feeling, when you're just completely swamped with information. And you really need to get your head around something complex, fast, but it's like, where do you even begin? How do you actually cut through all that noise and find what really matters? Well, imagine having, I don't know, a super smart assistant that could do exactly that for you. Not just, like, answer your questions, but actually take action on your behalf. That's pretty much what we're diving into today, the whole world of AI agents. For this deep dive, we've gathered a bunch of sources, mainly leaning on IBM technology, actually. And we're going to explore what these AI agents are, how they work, and maybe most importantly, look at some of their really cool real-world uses. Now, you might be thinking, okay, hang on. Are AI agents just another name for chatbots? Mad. That's a totally fair question. But here's the key difference, what really sets them apart. They're not just reacting to one prompt at a time. They can actually reason things out. They can act autonomously on their own to achieve specific goals. And crucially, they maintain a state. They remember past conversations, context.
Which lets them break down really complex jobs into smaller bits, subtasks. They can run these one after another, or even do several at once, in parallel. And then this is important, they adjust their plans based on what they learn as they go. It's all about taking smart actions to reach a defined goal.
Right. And what's really fascinating, I think, is that this isn't just theory anymore. We're way past that. These are actual solutions being used today, right now, in lots of different industries. So understanding how they fundamentally work, that core structure, helps you see how these advanced ideas turn into real benefits.
Absolutely. And the source material we looked at, it actually mentioned 10 different use cases. Pretty impressive. We're going to really unpack 3 of those first. How they connect with the Internet of Things, or IoT, how they use something called Retrieval Augmented Generation, RAG for short, and then how multiple agents can work together in these complex workflows. After we've gone deep on those 3, we'll do a sort of rapid fire round for the other 7, just give you a quick feel for what they do.
Okay, so we've said they can plan and execute, but what does that actually look like? Under the hood, is there like a standard way these agents operate, whether it's a simple virtual assistant or, I don't know, controlling a factory floor? Yeah, that's a great question. And if you zoom out a bit, it really does boil down to a fundamental iterative framework. Pretty much every AI agent, no matter what it's doing, generally follows 5 core steps or stages. There's the goal, the planner, memory, the executor, and finally, action. So the goal is just that. The clear objective the agent needs to achieve could be maximizing crop yield, like we'll discuss, or writing a blog post, or something critical like coordinating an emergency response, right? So once the goal is clear, the planner kicks in. Now, this is usually a large language model, an LLM, that's kind of the agent's brain. And crucially, it's given access to external tools. Think APIs. These APIs let it look up real-time info or interact with other software. It massively expands what it knows beyond its training data. Then there's memory, super important. It's where the agent keeps track of past actions, its history, relevant context. Could be the last time a field was watered, or chunks of documents stored smartly in a vector database, or even a shared map everyone uses in, say, a disaster situation. All that info from the planner, from memory, goes to the executor, and the executor figures out the concrete steps, the action plan. And finally, the action part. That's what connects to the real world or other systems. IoT controllers, maybe a document outline, emergency dispatch systems, whatever it needs to actually do the task. And this whole loop, it repeats, it's iterative, constantly updating with new data, and it's self-improving. It learns from results and gets better.
That framework definitely makes it clearer. But thinking about that action piece, are there common hurdles when these agents need to talk to all sorts of different real-world systems, like integration challenges?
That's a really good point. Yes, integration is often, well, it's critical. But the beauty here is how modular these agents are designed to be. That action component is built to be adaptable. It uses APIs, connectors, whatever's needed to basically translate the agent's digital plan into a real-world outcome. It bridges that gap. Let's actually make this concrete. Let's dive into that first use case. Agriculture, how AI agents are helping farmers boost yield, cut waste, especially using IoT devices. Okay, so in farming, the agent's goal is pretty straightforward: maximize the crop yield. The planner, the LLM, uses APIs to pull in real-time stuff, current weather forecasts, maybe specific soil moisture readings from sensors. This fresh data then gets combined in the agent's memory with historical info, like when was this field last watered, what were the yields last season. The executor looks at all that and decides the best action. Maybe turn on irrigation for Sector B for 2 hours. And then the action part connects directly with the farm's IoT controllers, the actual valves and pumps, and carries out that precise irrigation task.
Okay, and you mentioned that iterative self-improving thing. That sounds really powerful for farming. How does that learning actually happen? Can you walk us through that? It sounds almost like having this super patient, super smart farm manager working 24/7, just constantly tweaking things.
That's a perfect analogy, actually. It's not just following dumb rules.
Yeah.
After it does something, say, it irrigates, it keeps monitoring,
Mm-hmm.
using sensors to track crop growth, nutrient levels, maybe even visual checks from cameras. All that new data goes back into its memory, and the planner looks at it again. Okay, I did X, and now Y is happening. Over time, it figures out cause and effect. This much water, under these conditions, led to that much growth. So this constant feedback loop makes it way better at using resources efficiently.
Yeah.
It adapts to changing weather, optimizes water, fertilizer, to a level a human just couldn't manage across a large area. It's about efficiency, yeah, but also resilience, adapting in real time. That can mean less waste and bigger yields.
Okay, from farming, let's switch gears completely. Let's talk content creation. How can AI agents help write something like a blog post, but go beyond what basic generative AI can do, especially using this RAG thing, retrieval augmented generation?
Right, good transition. So for content, let's say the goal is write a blog post about solar energy benefits for students. Specific audience there. The planner uses its tools, its APIs to search for current solar stats, recent case studies, maybe relevant research papers, finds the latest stuff. It loads these documents, and this is where RAGA comes in big time. The agent takes these documents, splits them into manageable chunks, logical pieces of info. Then it stores these chunks in something called a vector database. Think of it like a super smart library. It doesn't just store the text, it understands the meaning, so it can instantly find the most relevant chunk when needed. This database becomes its specialized memory for this task. So when the executor actually starts writing the post, it's not just relying on the LLM's general knowledge, which might be outdated, right? Instead, it actively pulls the freshest, most relevant facts from that vector store, that ARG memory. So for the section on economics, it retrieves the latest cost per kilowatt numbers it found. The action then is to weave these facts into the blog post outline and, importantly, adjust the language and tone specifically for that student audience.
That iterative part sounds key again, refining the work. Does that mean the agent can actually, critique its own writing? How does that self-correction really work? Does it truly understand if the writing is good?
It absolutely can, yes. And that's a huge step beyond just generating text. After drafting a section, the agent can use its core LLM smarts to review what it wrote. It compares it against the original goal or maybe some quality rules you gave it. It might internally ask, is this section backed up well by the data I found? Or is this tone right for students? If it finds problems, maybe weak evidence or the tone is off, it doesn't just stop. It can go back to the planner, maybe refine its search terms to find better data, or tell the executor to rewrite that part with a different style. Now, the understanding is based on patterns and the data it has, not human consciousness, but its ability to self-assess and iterate based on the goal is what makes it so powerful. The limits are often about how clear the goal was and the quality of the info it can access.
Okay, powerful stuff. Let's shift now to a really high-stakes area. Disaster response. After a big earthquake or during massive wildfires, time is absolutely critical. You've got this flood of information, satellite images, social media posts, emergency calls, sensor data. It's just chaos. No single person could possibly track all of that at once. And that seems like exactly where multiple agents working together could be indispensable.
Exactly. Trying to coordinate something that complex and fast-moving like disaster response, it feels almost impossible for one person or even one system. So, how do multi-agent systems handle it? Well, the goal is clear: coordinate the emergency response effectively. But here, the planner isn't just one agent. It's usually a central coordinator agent working with a team of specialist agents. So you might have one specialist analyzing satellite pics for damaged buildings. Another one is constantly scanning Twitter, Facebook, looking for people asking for help. A third might be running simulations forecasting where the damage might spread, what resources will be needed soon. And each of these specialists feeds its findings back to that main coordinator planner. Their shared memory is often visualized as a common map or dashboard, a real-time picture of the situation that all agents can see and update. So if that social media agent finds urgent pleas from a certain neighborhood, it flags it on the map instantly. The executor, guided by the coordinator, then recommends the best actions based on this complete up to the second picture. And the action component then orchestrates the real response, telling fire trucks where to go via dispatch systems, routing ambulances efficiently, pushing out evacuation alerts to specific zones.
Wow. What really hits me there is the power of them working in parallel. They're not just going step by step. They're tackling different pieces of the puzzle: imagery, social media, simulation, all at the same time. That's something a human team just can't replicate at that speed and scale. It really feels like a game changer for those critical situations.
Okay, so we've dug into agriculture IoT, content RAG, and multi-agent disaster response. Really fascinating examples. But the source mentioned 10 use cases, and we promised. So let's do that rapid fire round for the other 7. Just give us the quick fit on what each one does, maybe the core impact.
All right, rapid fire. Let's go. First, banking and finance. Here, agents are great at real-time stream processing. They watch transaction data fly by, using anomaly detection models to spot potential fraud almost instantly, way faster than humans for high volumes.
Okay, fraud detection. Got it. Next.
Customer experience. Agents use sentiment analysis. They figure out the customer's emotional tone during a chat or call, and they can adjust their own responses on the fly, maybe become more empathetic or de-escalate tension. Adapting to emotions.
Yeah.
Interesting. What about healthcare?
Healthcare. We see multi-agent setups again. You might have sub-agents doing specific things, like one analyzing lab results for anomalies, another managing prescription refills to avoid conflicts or missed doses, maybe even optimizing hospital scheduling.
Makes sense. Specialized tasks. HR.
Human resources. Big focus on workflow automation. Think onboarding a new employee, it's usually a multi-step process. Agents can handle that, integrating with big HR systems like Workday or SAP to set up accounts, schedule training, etc.
Automating complex workflows. Okay.
Yeah.
IT operations.
IT operations. Automated remediation is key here. Imagine thousands of system alerts firing off. Agents can sift through them, figure out the root cause of a problem, and then automatically run scripts to fix it, often before a human even notices.
Fixing problems automatically. Very useful. Supply chain.
Supply chain. Predictive analytics is the name of the game. Agents forecast demand by looking at market trends, historical sales, even external factors like weather impacting shipments. Helps optimize inventory.
Better forecasting. And the last one, transportation.
Yep, transportation. Dynamic replanning. Think delivery trucks or ride sharing. Agents constantly recalculate the best routes as traffic jams pop up, weather changes, or new pickups are added. Always optimizing for speed and efficiency.
That's quite a list. And it's pretty amazing how that same basic pattern, goal, planner, memory, executor, action, applies across such different fields.
Yeah.
Are there areas, though, where this agent approach still struggles? Or where maybe this model isn't quite the right fit yet?
Oh, absolutely. That's a really important point. While this framework is powerful, its success really depends on a few things. How clearly can you define the goal? How good is the data the agent gets from its memory and tools? How reliable are the systems it interacts with for the action? So problems that are super ambiguous, highly unstructured, or ones that need genuine human empathy, deep nuance, those are still really challenging. But, the underlying tech, the LLMs, the tools are getting better so fast, the boundaries are constantly shifting.
Right. So thinking about all this, what does it really mean for you listening right now? I think understanding these basic mechanics, goal, planner, memory, executor, action, helps demystify things a bit. When you see some complex automated system out there, you can start to see the underlying logic. It helps make sense of this increasingly automated world we're living in. Makes you maybe more informed about what's happening behind the scenes.
And building on that, here's something to chew on. Think about that self-improving aspect we mentioned. These agents aren't just doing tasks. Because they learn iteratively, they could potentially be evolving their own ways of making decisions over time. What does that imply for the future? Systems that learn and adapt way beyond how we initially programmed them. Maybe finding solutions we didn't even think of. It's a profound thought.
Definitely something to think about. So maybe consider how that framework, goal, planner, memory, executor, action might pop up in other areas of your own life or work. What could happen if you started looking at systems or even problems through that particular lens? What new possibilities might open up?